So hello everyone, today in this video we are going to talk about the locker register present in the STM32. So without wasting any time, let's go to the data sheet. So in the data sheet, you'll see there is one register, port configuration lock register, or simply you can say lock register, that can be used to lock the configuration of the GPIO pins that you're going to use. So whatever configuration you do in CRL, configuration register low and configuration register high, can be locked after you have done the configuration with the help of this lock register. So today in this video, I'll show you how to use this lock register, what is the sequence that you have to follow in order to lock any configuration of any pin. So let's go to the program that I've written. I'm not going to waste your time by writing the program in the video. I've already written the program. So in this video, I'm going to assume that you already know how to use CRH, control register high, and how to turn on LEDs, simple GPIO enabling, and how to toggle LEDs like this. Okay. So here in this program, I've written a very simple program. So in this program, what we are doing is simply I'm reading one input from PB9. So in the PB9, I have connected a push button. I'll show you here. So this is my board. This LED you can see here, this is connected to PB9. And when I press the button, my LED should start toggling. So this is the toggling operation that I'm performing here. So there is one onboard LED in this blue pill board that is connected to PC13. So here in this program, I'm just toggling this port C13 pin. Okay. And if the condition is not true, I'm just turning off the LED. So after the configuration is done, here you'll see I'm performing the locking sequence. This locking sequence you can find in the data sheet. So in the data sheet, you'll see to lock any configuration of any pin, this is the sequence that you have to perform. You have to write 1, then write 0, then again write 1, and then read 0, and then there is read 1 that is optional, so I'm not doing it. And this locking sequence you have to perform after you've written this lock bit. Okay, so here in my application, let's say I want to um, lock the configuration of PC13. After I've done this configuration over here, I want to lock the configuration of my pin PC13. So in that case, what I'll do is first I have to write 1 in this 13th position. Okay, then it will freeze the bits, corresponding bits from CRL and CRH, the configuration register low or configuration register high, depending on which pin you are using. So in my case, it will be CRH since I'm using 13th pin. Okay, so here in the data sheet also it is mentioned, once you write 1 in the pin position, pin number, it locks the or freezes the corresponding 4 bits of the control register. So these 4 bits are nothing but your mode and the configuration bits. So let's say you've written 13. In my case, I've written 1 in the 13th position. So it's going to lock these 4 bits, configuration 13 and mode 13. These 4 bits it's going to lock. Locking means you cannot write anything else. It will freeze. Okay. So to perform the locking sequence, this is what I've done here. Okay. So I'm writing the value in hex. Make sure you're not performing any OR operation while writing this. Okay. Otherwise, you'll break this sequence. So if you go to the locking sequence in the data sheet, I mean the reference manual, sorry, you'll see there is a specific sequence that you have to perform. So while performing this sequence, you should not perform OR operation. Okay, you cannot do the OR operation. So let's say this is the normal syntax that we follow, right, when writing 1 or 0 in any position. So here in this case, you should not write like this. Okay, you should not write like this, otherwise you're going to break the sequence, because in between uh, writing the data to your register, this 13th bit position, you're going to break the sequence before because you're performing OR operation as well. Okay, so what we're going to do is, instead of performing OR operation, we'll directly write our data in the form of hexadecimal. You can also use binary, but I prefer using hexadecimal data. So now let's see, where did this 12,000 come from? So if I open my calculator, so this 1213, I mean 12,000 is nothing but see, this is the binary data. So this 12,000 is nothing but 1 written in the 13th position. Okay, 13th position. So in the binary, it will actually be 14th position since the index starts from 0. Hence, it is in the 14th position. And then I'm writing 1 in this 16th position. That is actually my lock key. So this is where we have to, this bit is actually where we have to perform this sequence, lock key sequence. Okay. So since the first step of the sequence is write 1, hence I'm writing 1 over here. Okay. And since I want to lock the 13th pin, I'm writing 1 here as well. So when I write these values in binary, this is the data that I get in hex, 12,000. Next is 2000. Okay. Since in the data sheet it says next we have to write 0, that's why I'm writing 2000. So 2000 is also nothing but 1 written in the 13th bit position, or binary wise 14th position. Okay. So this will be 13th bit position, and if you start counting from 0, it will be 14th position. And again I'm writing 1. Okay, I'm just following this sequence that they have given here, writing 1 again. Then at last I'm reading value. Okay, then you have to read value. So to read value, there are two things that you can do. Okay, first one is that you can create, let's say you create a dummy variable. So I'll call it dummy. Okay, it'll show me warning, no problem. Then you can read your data in this dummy variable. Okay, otherwise if you don't want to do that, you can just simply perform an AND operation and this will work as well. Okay, so I prefer using the AND operation. And again, here it will show me warning because I'm not storing the result that is produced by performing this AND operation anywhere in the variable. Yeah. Okay, so let's see the working. So first, let's see what happens when I'm performing this locking sequence after the configuration is done. Okay, so first I'm performing all the configuration, I'm setting all the CRH bits, and then I'm locking the bits. So in that case, it should work properly. So here you'll see when I press the button, the LED starts toggling, which is what I've written in the program. It's correct. Now what we'll do is we'll change the sequence. I mean, we'll change where we are performing this sequence. So instead of performing this locking sequence after all the bits are set, I'll perform it beforehand. Okay. So now our expected result is that it should not blink the LED since we are going to lock the register. Okay. So the value of ODR will change since it is not affected by the locker register. Okay. In the data sheet, we can see it only affects the bits in the CRL and CRH register. But these statements will have no significance. They'll not be able to perform anything because we are locking the GPIO-C pin number 13 beforehand. Okay. And one more thing, these statements will still work because we are performing the locking operation only in the GPIO-C port, and that too in only 13th pin position. So if you do any configuration in any pin apart from pin 13 in GPIO-C, it will still work. So let's see our output in our debug mode. So here I've opened the GPIO-C peripheral. So you'll see the default value of CRH, or the configuration register high, by default is all 4s, and the value of this CNH, or sorry, the CRH configuration register high will not change even though we have written these statements over here, because we are performing the locking sequence beforehand. So now when I run the program, you'll see nothing changes. But here in the locker register, you can see we have locked the pin number 13, and we have locked the lock key as well. Okay. Now if I show you the actual output in the board, you'll see when I press the button, LED will not blink because we have locked the register, and hence it was not able to be configured as output. But in the ODR, you'll see when I press the button, it still changes the value of ODR. Okay, since ODR is not affected by locker register. But we are not able to see this output value since this PC13 is not configured as output right now. This is all. Thank you for your time.